Last night, while you slept, something moved through your house. Not a burglar, not a ghost, something smaller. Something that has been inside your walls longer than you have been alive. Something that, by the time you woke up this morning, had already updated its map of every room you live in. Your kitchen, your hallway, the space under your bed. All of it, logged, filed, and transmitted to every other member of its colony before sunrise. This is not a theory. This is not an exaggeration. This is what the science of insect cognition has been quietly confirming for the last 2 decades in peer-reviewed journals that almost nobody outside a university laboratory has read. By the end of this video, you will understand exactly how they do it, exactly how far the map extends, and exactly what it means that you have been living inside someone else's database this entire time. And the answer to that last question is the most unsettling thing we have ever covered on this channel. This is Glitch Wild. Subscribe now because we are just getting started. Here is the first thing most people get wrong. When you see a cockroach cross your kitchen floor at 2 a.m., your instinct calls it random, panic behavior, a pest running blind. It is not running blind. Periplaneta americana, the American cockroach, measuring approximately 4 centimeters or just under 2 inches in length, carries a spatial navigation system that researchers at the University of Cologne documented in a landmark 2020 study as functioning on the same fundamental principles as mammalian GPS. The cockroach's mushroom body, a neural structure sitting inside a brain roughly the size of a sesame seed, encodes spatial relationships between landmarks, distances, and directional memory with a precision that is not random and is not panicked. It is methodical. The cockroach crossing your floor at 2 a.m. is not lost. It is updating a map it has been building since the first night it entered your home. And here is what that map contains. Every heat signature in every room, every water source, every food residue on every surface, every gap, every crack, every entry and exit point in your walls, your floors, your ceiling. Your home, the place you designed and paid for and believe you control, exists inside another creature's detailed spatial database. But a map is only as dangerous as what can be done with it, and what can be done with it is where this gets dark. To understand what a cockroach does with its spatial map, you first need to understand the machinery generating it. A cockroach's brain contains approximately 1 million neurons. A human brain contains 86 billion. That gap sounds reassuring. It should not. Because what matters in neuroscience is not the quantity of neurons, it is the architecture connecting them. The cockroach's mushroom body, the neural structure responsible for learning, memory, and spatial orientation, is not a primitive system. It is a highly specialized parallel processing architecture that researchers at the University of Cologne and the University of Constance have spent decades studying precisely because of how sophisticated it is. In 2020, those researchers confirmed that cockroaches demonstrate individual learning abilities consistent with vertebrates. Their memory is not a fixed biological program running the same route every time. It updates. When your kitchen layout changes, when you move a chair, rearrange furniture, seal a crack, the cockroach's spatial memory does not break. It recalibrates. It files the update. The new version of the map replaces the old one without erasing what came before. In 2022, a study on Blaptica dubia cockroaches found something that pushed this even further. Cockroaches that observed another cockroach navigate a maze had dopamine levels 30 times higher than cockroaches that navigated alone, a biological signature of active, reward-driven social learning. They are not just mapping your house, they are learning from each other how to do it better. But the map staying inside one insect would be manageable, almost acceptable. The map does not stay inside one insect. And this is where I need you to stay with me. Your home has a second set of corridors. You cannot see them, you did not build them, but they exist in every wall, every baseboard, every gap between your appliances, and they are marked. Cockroaches communicate spatial information through chemical signals called pheromones, specifically trail pheromones, compounds secreted from glands on the insect's body and deposited onto surfaces as it moves through your home. These trails are not random scent marks, they are structured navigational data. A trail pheromone indicates direction. It encodes information about food source quality, distance, and route efficiency. When another cockroach encounters the trail, its antennae read the chemical gradient, processing not just where the trail leads, but how recently it was laid and whether the destination is still viable. Your kitchen wall, from a cockroach's perspective, is not blank. It is annotated. And here is what that means for the map. The spatial data that one cockroach builds during its nightly survey of your home does not stay with that cockroach. It leaves, encoded in chemical signals that other members of the colony can read, interpret, and use to navigate spaces they have never personally entered. A cockroach that has never been in your bedroom may already know where your bed is. Not because it explored, because something else did and left the directions behind. By the way, if you are watching this and you have not yet subscribed to Glitch Wild, now is the moment. Because what comes next is the part of this story that most people never hear, and we have a lot more where this came from. In 2022, researchers published a study on social learning and spatial navigation in Blaptica dubia cockroaches that the mainstream science press barely covered. It should have been front-page news. The experiment was designed to answer one question: can a cockroach learn to navigate a spatial environment by watching another cockroach do it first? The answer was yes. Cockroaches that observed a model navigate a cross-shaped maze subsequently navigated the same maze faster, with more precision, and with dopamine levels 30 times higher than cockroaches that navigated without prior observation. The dopamine finding is the critical detail. In insect neuroscience, dopamine is not a happiness chemical. It is a learning signal, a biological marker that something important has been encoded, something worth remembering, something worth passing on. The cockroaches that watched were not passively absorbing information. Their brains were actively filing it, tagging it with the same neurochemical reward signal that drives learning in mammals. What does this mean in the context of your home? It means the spatial intelligence a cockroach builds while navigating your kitchen is not trapped in one insect. It is portable. It is transmissible. Through direct observation, through chemical trails, through a biological network that has been operating inside your walls since the day the first insect found its way inside. The map of your home exists in a distributed system. No single insect holds all of it. All of them hold part of it. And that is what makes the climax of this story the thing I have been building toward since the first word. Come back to last night. You were asleep. Your lights were off. Your house was quiet. Inside your walls, inside your cabinets, inside the gap between your refrigerator and the floor, the network was active. Chemical trails updated. Dopamine-tagged spatial data moved through a colony that does not sleep on your schedule. New routes were tested. Old routes were confirmed or reclassified. The map of your home was revised, cross-referenced, and redistributed before your alarm went off. Every room you live in, including the ones you keep clean, the ones you have never seen an insect in, the ones you believe are perfectly sealed, exists in a spatial database that is collectively maintained by a colony you may not even know is there. And here is the thing that makes this the #1 most disturbing fact we have covered on this channel. The colony does not require your participation to update the map. You do not have to leave food out. You do not have to leave gaps unsealed. You do not have to do anything wrong at all. The map updates because you live there. Because you generate heat, moisture, food residue, and movement. The 4 biological inputs the cockroach navigation system treats as landmarks. Your presence is the data. Your daily routine is the information. Research from the University of Cologne confirmed that cockroach spatial memory persists for at least 72 hours following a single learning trial, meaning a route confirmed 3 nights ago is still active in the colony's collective database tonight. You are being mapped continuously, passively, without your knowledge and without your consent. Not because you did anything wrong, because you live somewhere warm. And the insect inside your walls has had 300 million years, 300 million, to perfect the system it is running on you. Your home is not just yours. It never was. We spend our lives believing our homes are our own. The locked door, the sealed window, the space we control completely. What the science of insect cognition has spent 2 decades quietly confirming is that the boundary between your space and theirs is not a wall. It is a data point. You are not being targeted. You are not in danger. You are simply a landmark in a map that was started before you moved in and will continue long after you leave. That is not a horror story. It is something stranger than that. It is the truth about who shares the world with us and how much more carefully they have been paying attention than we have. Subscribe to Glitch Wild to uncover the next glitch in the natural world. Turn on notifications. And when you are done here, watch this next, because what we found about how animals track and use human behavior inside domestic spaces goes even deeper than what we covered today. You are going to want to know.